So not understanding their process, looking at data that was available on a minute, on a second basis from a 30,000 foot view,
Right.
it gives you a 30,000 foot understanding, right?
Yeah.
If this is data that we care about in real time, right, then the deviation cost that we're calculating at the end of an hour, right? Wouldn't you like to know that at the beginning of the hour instead of at the end of the hour? Like, hey guys, if we keep running this way by the end of the week, it's going to cost us $10,000.
Welcome to Manufacturing Insiders. Today I have Kevin White with me. He is a senior consultant with Enhanced Information Solutions. We actually previously had a guest, Joe Cody, that talked a lot about the operational technology side of things. Kevin is an expert in digital transformation, and so not just the security aspects of that, but also, the necessity of it. And this is something I preach a lot on the podcast about, the necessity for digital transformation. Really what that means is just using technology to enable your manufacturing business to stay competitive in the long term. And I think, as we all know, this technology is moving very quickly. We've all started to use these large language models in our daily lives. There's a lot of advancements in robotics. And so we really, really need to be thinking about ways that we can kind of embrace this digital transformation. One quick note, if you're interested in joining the podcast or learning more about it, you can go to manufacturinginsiders.com. We'd love to have you on as a guest if you're a leader in the manufacturing space. If not, we'd love if you just listen to the content and learn from, the insights that a lot of our great guests that have had. So welcome to Manufacturing Insiders, Kevin.
Awesome. Appreciate it, Nate. Thanks for having me. Appreciate it.
Absolutely. So how do you define digital transformation?
So when I look at digital transformation, I'm really looking at what technology is already in the plant and how is it being utilized currently to help operations move forward. Really, to standardize is really what we're looking for. I know a lot of people, when they think digital transformation, the first thing that comes to their mind is optimization, right? Which is great. How can we get that last little bit out? But from being in manufacturing facilities, if you go look at it, right, if you talk about how much utilization is going on, things of that nature, a lot of the opportunity comes in standardization. If you could do it the same way twice, every single time without changes, value stream becomes easier, uses become easier. And there's a lot of digital information out there that can tell you, hey, we're not doing it the same way we did it last time. We should fix this. And that's really what I see digital transformation is. How do we do it all the same way each time?
And I think that's the big problem a lot of manufacturers run into, and kind of what I'm talking, I'm trying to encompass the perspective of a job shop. So a lot of these guys look at automation and look at robotics and say, we do too many different things. We got this guy switching over to this role. We wear a lot of hats in the company. They don't see a clear path to that standardization that you're talking about. And my gut feeling is that maybe they're looking in the wrong places. And so I wonder if maybe you can help us understand that a little bit more.
Absolutely. And I'll tell you, most of the customers I work with, automation is a future thought, right? Sure, I wish I could. Most of us can't automate. Most of us don't have the capital to go in and automate these things. So if we know automation is the ideal, right? Okay, fine. No humans. We're having it all done by robots, right? We decide to go there. Right. How many of us are having that right around the corner? Very few. So a lot of us have to figure out, well, how do we get those benefits of what we know comes from automation, doing it the same way with humans, right? And that's really where digital transformation has got the biggest opportunity, is the interaction with humans, right? It's not to make that machine do better. The machine can only do so much better. It's to make our humans do better. And this really works a lot when you look in the operators who are on the ground and understand their systems really well. You can really tell a system running with that knowledge. You can also quickly tell when a new operator comes in without that knowledge, what happens, how quickly the system can get out of standardization and how quickly, right? I bring up a scenario of an operator coming in on Monday morning, right? A senior operator. And the first thing they do is they look at the logs to see who was on shift over the weekend, because they can tell by that how bad the system is going to be Monday morning and how long it's going to take them to figure out how to get everything out, all straightened up again. And depending on who it is, You may even have an idea of what steps they took that were wrong at the wrong time and get ahead of it, right? And every operator knows this because that level of knowledge gap, right? So
Right.
when we talk about automation, I'm not talking about getting robots to do people's jobs. I don't see that happening. I think digital transformation is using that digital technology to help bring us all up to a minor level of knowledge where we all can be the same level of knowledge as a baseline. After that,
Okay.
human performance takes over from there.
So functionally, what does that look like? In the example that you gave where you got the senior guy coming on shift, looking at the log, what could we do to streamline that or to
Yep.
make it better?
And so someone's going to go, well, that person over the weekend has to learn like I do. And that's a bummer because that's a step change of knowledge, right? What I saw from my background in the military was what we called watch team backup, right? We never took an action without having someone else around us to double check us because humans are fallible. We've got to know that, right? We cannot assume perfection out of humans. So,
Right.
what can we do to help them out? And someone will say, well, training. Great. That's only so far, right? What do we give them in this situation other than hoping they can remember something? Right.
Hmm.
And so I look at digital technology, maybe a digital workflow. Hey, this is the situation. I need to follow through with this, right? Not just a paper procedure that if they get a chance to go to it, then they can look at the steps and they still have to synthesize these things. Use the digital technology to not say, hey, choose between door A, B, and C, because the computer, the system sensing what's going on in the plant, know that there's an upset and the required action should be go do this, right? We
Right.
can make a computer get to that point. So let's give that new operator, when that system arises, not all these different stimulus to figure out what's going on. And as something bad's happening, let's give them at least the first door to go through. And I'm not
Right.
saying you have to handhold them to the very end because nothing will ever be automated that much. But at least let's give them that first few bumper lanes so we know they can get down the right path. And that's
Right.
compassionate. And that's what we'd want as a new operator as well, right? None of us would want to be the person who had to call somebody on the weekend going, I don't remember the training I got. I don't know what's going on. Most of us would never
Right.
do that. So on Monday, it gets even worse, right? And so that digital watch team backup then leverages the plant knowing certain things without removing any humans from it and allowing that to back up our most vulnerable, who's our new operator, who we've got to get into this process because our senior operator, guess what? We're not having you in on the weekends. We don't want you to have to work forever. You've got to be able to retire, but the only way is that knowledge transfer. And I see
Hmm.
digital transformation as being that knowledge transfer so that we can at
Okay.
least have that entry level of knowledge all throughout the team.
Yeah, and that's incredibly important, and and I say this all the time, but the workforce issue is not going to get any better.
No,
We have the largest generation in the history of our country aging out of the workforce, replaced by a much, much smaller generation. So even if you did have the same percentage of people that were interested in working in manufacturing jobs, you still wouldn't have as many people.
not at all. Not at all. And you see the loss in knowledge with that, right? And that institutional knowledge that goes with that. This actually all came from when I was a manufacturing engineer. We had this amazing maintenance tech, and I would call him out because something was going on with a kettle that wasn't heating up right. I couldn't tell if it was chemical, mechanical, or electrical because there's so many interlocking systems. I didn't quite sure how they all worked. He came out and he did the simplest troubleshooting. He tapped on the gauge, he kicked on a pipe, he toggled the number, and he goes, "Yep, here's your problem." I said, "That's amazing. How'd you do that?" Right? And I could have known if I would have known what he knew. Right now, that used to be job security. Right? That used to be
Right.
something that he's got to have that knowledge, or else we're going to replace him. And we're
Right.
we're not at that point anymore. We're at the point now where, hey, I need you to pass on that really important information so I can operate safely.
Yeah.
Right? Because I don't want to mess up and hurt someone else because I'm not where I need to be. And if you knew
Right.
you could have given me that knowledge ahead of time so I didn't hurt somebody, that's kind of bad in hindsight, right? So I looked and I said, "What could you?" And he goes, "Oh, it's easy. Here's the flow chart going on in his head." He spoke it out to me. I put it on a piece of paper, said, "Like this?" He goes, "Yeah, absolutely." I go, "Would you mind if I give that to the kettle operator? That way, instead of you coming out to have to assess this, because I know you're on another job, this can't be easy for you. You let them do this first round of checks, right? We've talked
Hmm.
about this is total productive maintenance, right? This is how do you do the frontline checks. And let's figure this out so then I don't have to call you away. Your knowledge has been transferred. You've helped me out. Now I know I need an electrical
Right.
vendor for this. And let's work that together. That doesn't take you out of this role. It
Right.
actually makes you key and critical because you're defining the decisions that we're going to make every single day. And really, if
So
you
that's, I mean,
empower operators to hold that, yeah,
that's an important point too. I mean, because there is a little bit of diplomacy going on here, and there is a little bit of the people side of things. While you're making this sort of a digital transformation, your communications need to be in order.
absolutely. And I think in manufacturing, that's our biggest issue is change management, right? Is that we hear you said automation, and my stomach hurts. I'm like, great, so somebody doesn't have a job. That was the first. And again, I'm not even going to get replaced by this. And the thought alone is that much of a Pavlovian response. And think
Hmm.
about if you've been told this as someone who has tons of information, tons of knowledge, and every time someone asks you for it, you feel that's the last time they're going to ask you because now they've gotten everything out of you they need. Right? That's a very
Hmm.
transactional feeling. It doesn't really help with teamwork and morale this way. If we
Right.
really look at it as, hey man, your knowledge, hey, your experience can keep us safe, can keep us better, right? Not so we make more money, not so we just, but so we operate the same way every time, right? So that your day when you come in to do whatever you're doing doesn't start with you pulling your hair out because you're so frustrated. That's not the kind of manufacturing environment I want to work in, right? I
Right.
want to come in, and if you ask any manufacturing engineer, and I've done this across utilities, what is your best day? And the best day is when you come in and everyone's just like, really? No, nothing, right? And you're like, are we missing something? And you go, wow. So this is what it could be like. Those are the worst days because those are where you feel, okay, this is it's in mode. You know something's going to happen, but those are the worst because you see the mountaintop. You know it could happen
Hmm.
with standardization and what you'd look for. Think about if
Right.
every single day was that day. The first time you get a wobble in anything, you'd be aware in a heartbeat. You'd be like, uh-oh,
Hmm.
what's that sound?
Yep.
Because everything's been quiet, right? That's the standardization, that digital transformation, interacting with humans, we could really get to. Where we could say,
Sure.
hey, man, start doing that. That's real time, right? Of course, then future state being like, I wonder if we could figure this out before it ever happened. Wonder if there's something else before this we can look at. The only way
Right.
we ever get to that point, though, is once we remove all the noise, and we're in a standard system.
So, and that sounds very utopian. So, what do you do? What are the physical steps we take now? So, let's say I'm that job shop. This is an intriguing conversation. I know that some of my guys are aging out. I know I need to have this knowledge transfer occur. What do I physically do right now?
Yep. So the way when I go to a plant floor to figure out what's important and what's not is you talk to the guys, right? So I'll just ask questions like, "What kind of pump is that?" And I'm like, I don't know. Cool. You don't care about that, right? Does that pump have anything to do with this process? I don't know. It's plugged in every now and then. Okay. You go to another pump. You go, what about that pump? What kind of pump? Oh, that's a such and such. You can lay who it was, when it was last repaired. By the way, if the hertz are off by 5, it messes with our mixing downstream. So you really got to watch out. Okay, that's an important thing. So if you
Hmm.
ask any operator, and again, I put the limit at 3 because I'm not the brightest guy. I got to keep it simple. 3 is the magic number, right? What are the top 3 things that you care about? What are the outputs you care about? If you had to walk around and could only look at 3 things, and it doesn't have to be a number, it could be a synthesis of things, right? But what would those 3 things be? Okay, cool. Describe to me how your brain figures out when that thing is good and when that thing is bad, right? What is the definition of each of those? What we're really breaking down to is, does actual equal expected? Because if you can check those 3 things and actual equals expected, green thumbs up. If any of those are not actual equals expected, you have a red thumbs down and you should be able to investigate, right?
Right.
So if you ask that person those questions, you now get to what are those 3 things? And now, Nate, I know you love data from the floor. So now instead of going, oh my God, look at everything that's instrumented. Look at all this cool. We can connect to the cloud. Oh, we can interconnect these. Oh, edge transmissions, all this scary stuff. We go, I don't need any of that, right? None of that was in my problem set. I need these 5 data points to solve these 3 problems. So those
Right.
5 data points are now critical, absolutely
Right.
critical. If they're
Right.
captured on a piece of paper, you're going to have a hard time telling me how critical it is if you have a human recording this number, right? It can't be that
Right.
critical. The other numbers, the other values you need should be coming from real-time variables, which you have digital access to,
Yep.
or a table of numbers that somebody knows in the back of their head or knows to look up from a book somewhere. Well, those should probably be digitized too somewhere so we know where those are coming from. So if
Right.
you can take each of those input and make sure they're digital, then the stuff that your operator thinks is super important, what they'd be checking, those 3 things can be checked automatically. Actual
Right.
equals expected in real time, right? So
And
now
like
you're
your
helping that
example,
operator.
And like your example with, with the noise and the silence, where all of a sudden now you can start to notice other things. So now that you know that those three items are in hand, then you start to recognize patterns and you can see what's upstream and downstream of that.
Huge. Huge. And that'll drive you to your next, oh, wait, this is important too. Okay, I need these data points. And so as I'm working with manufacturing plants, the biggest part, right, besides the change management is being overwhelmed, like you said, Nate. Where do I even start with this, right? How does this even apply to what I'm doing daily? And the answer is because all you see when you look on TV is how AI is connecting everything. You're like, but I got paper logs. That's not for me. You're right. It's not for you. Right. But what I'm telling you is that doesn't mean you don't have to go digital. Right. Everybody who's on that cutting edge. Right. The only way you get there is by taking those initial steps. And those steps are big and overwhelming. So then in prioritizing them, right, start with what's important to you now. Right. What are the metrics important to you now? Cool. Digitize that. And like you said, Nate, as you start doing that, you're taking bites of the elephant. Right. You're moving down, you're solving problems. If technology, and this is always the biggest part on the floor, right? As an engineer, it's like, oh, we could do ... When an operator hears that, they're like, oh God, slam my head into a wall. What the heck is this guy coming up with? It's going to take my time. It's not going to work. It's going to fulfill their ego, whatever it is, right? Because we don't have time for that. We got so many have-tos. We don't get to move on to, it'd be nice, right? Once we get done with all the have-tos and it's so silent, we're like, well, I guess we should start improving things now, right? Then that's when you get to that point. None of us, I'm pretty sure if you take an honest poll, none of us are there. So it's really on the fact that, sure, are robots going to take your job? No, right? Because, man, you're still on paper logs. You've got a while to go before that occurs, right? So don't worry about that transfer. Right. Don't think about it that way. Right. People will always be where the gaps do not have machines. Right. We will be there.
Right.
And where we can use technologies to make sure that when humans are doing stuff, it's done the same way. It's done safely. It's done reliably. It's done in a way that if it's going to mechanically fail, we know before, so we don't hurt anybody else, right? We know that if it's going to have a chemical reaction, that we're away from that, so we remove humans from danger points, right? Technology should be doing that. Digital transformation should be doing that. It should make our life easier. It should make us not recording numbers that the machines already know. Right? I look at digital transformation as how do we remove what humans are doing dangerously and boringly, right? And make the machines do that part.
Yeah, and I think that's the big point. That's the big point. I also try to emphasize, and a lot of my guests have about automation, is we're not talking about taking people's jobs. We're talking about filling jobs that we can't find anybody for anyway.
Correct.
Yeah.
Correct. Nor should we be doing for some of them, right? We've done things because we had enough bodies for a long time, right? We did things in a really inefficient and sometimes unsafe way, right?
Yeah.
And we were able to get away with it because we're like, oh, that's okay. We'll have the new guy do it. And you're like, no, nobody should be doing that. We're like, you can buy a robot to do that. In case it goes wrong, the robot gets hurt, not the human. They're like, yeah, but that robot's pretty expensive. And you're like, how much does Jimmy cost? And we could never get that answer, right?
And now and how much is his health insurance?
Exactly.
I was in a metal finishing plant. You got your zinc, nickel plating, all these different electroplating, and your nose burns in this facility because of the hydrochloric acid vapor in the air. And I'm thinking, I walk out and I got a little, and I'm thinking to myself, if I did this every day for 20 years, what do my lungs look like?
Yeah.
And it's like, you need robots for this. This is, this cannot, and you're absolutely right. The jobs that are unsafe for humans, that are tedious, boring, and dangerous, absolutely need to be fixed. And I think one of the big problems is, we're talking about this use case, identifying the three things, starting to record those three things that are being manually recorded currently. A lot of the business owners, the leadership is thinking, well, and even if you talk to the guy on the floor that's doing, he's like, it only takes me 10 minutes. Yeah, that only takes me 15 minutes. And so it's hard for these guys to make a business case for it. And I think it makes it difficult for people like us to convey the sense of urgency where, okay, it's not just the 15 minutes you're saving. It's what you can do with the data. It's what it's going to allow you then to investigate and then start to change things that maybe take an hour. in 2 hours, in 3 hours, and eventually you replace an entire person with automation.
Well, and I'll tell you, there's a really interesting use case I had with a customer, because you bring to the point of, if you spend all this money invested on this real time digital information, right? It's because that information is really important, right? And if we get to the point like we talked about, those 5 points, if those are digital and you want to know those in real time because they drive these metrics, you don't want that time lag, right? Because that time lag is delay of information, like you said, delay opportunity cost that you can make, right? So I had a customer who did a daily report, right, on consumption of fuel, and then figured out efficiency of their burners during this time. They did it at the end of the day. So they averaged fuel usage and an output, I believe. And so at the end of the day, they look like they're running awesome every single day. What I did was I took the hourly information and aggregated it hourly, because this information was literally coming out every second. They said, we don't need it that granular, but give it to me every hour instead of every day. Right. So instead of aggregating the data all day long, we're doing it hourly. And I give them the answer at the end, and I go, wow, you guys have lost a lot of money from inefficiency in these burners. And they said, what? The reason was, once they looked at it, they found that during their startup, they were under their target efficiency line. So they were losing money during that time. Halfway through the day, once these burners got up and humming, they were running at a higher efficiency than they had even calculated was possible, that they used as their baseline. So they ran super efficiently in their calculation, making money for the second half of the day. At midnight each night, it was almost exactly even and looked like they had run on their target all day long. Neither making money or losing money. So not understanding their process, looking at data that was available on a minute, on a second basis from a 30,000 foot view,
right?
It gives you a 30,000 foot understanding, right?
Yeah.
If this is data that we care about in real time, right, then the deviation cost that we're calculating at the end of an hour, right? Wouldn't you like to know that at the beginning of the hour instead of at the end of the hour? Like, hey guys, if we keep running this way by the end of the week, it's going to cost us $10,000. You'd go, hey, stop running that way. Now, the only way to do that, right, is to have that data as soon as it's created, be analyzed, right?
Yeah.
Anything else that a manager's talking about is all time lag.
Right.
Manual recording. Believe me, I know from the plants, going and aggregating, pulling that spreadsheet together, managing that spreadsheet, cleaning up that spreadsheet, adding in bad data point corrections, right? Making sure it's all right to get to that person who then's going to make a decision. So you've added layers, unnecessary layers for synthesis. We just talked about this. If you know how it's going to be synthesized by talking to a person, think how easy it is to look at a spreadsheet and figure out how it's being synthesized. If you hand me a spreadsheet, in a heartbeat, we can go, oh, cool. So you're looking at these three data points through all these calculations, through all this massaging to get here. Cool. Those are all right from your plant floor right now. Why are you gathering these at the end of the day? These could be calculated in real time. Right. And that's where we see a lot of this is we're putting humans in place for all the aggregation, for all the summarization, for all the contextualization, all that math that goes with it. We're making humans do stuff that Excel spreadsheets do, which a computer could do automatically. So to their point, it's only 15 minutes here or there, but you're right. You add up those hours and those minutes of time to take, that's a lost opportunity cost. But then think about the information that you're losing the granularity on that you're paying to get at that moment and you're not using until way later as a postmortem, right? The ideal for us in manufacturing, right, has always been predictive. But before you get to predictive, right, before you can see the future, you got to be running at the speed of light, right? You've got to be literally on that break point, which means as an event happens, you know about it, you react, right? That's the ideal, right? To maintain exactly where we are. None of us are at that speed of light yet. So that means none of us can truly see the future because you have to see the way it looks, right? So what I'm saying is for us to get to that speed of light, the closest we can in operations is doing that is when a digital signal is created, that's captured. And the next part would be is when a human writes a value down for some value. Those are the two real-time instances, which means that synthesis should occur when those two data points occur. So that's when you care about it, is right then, not afterwards. And if you're doing it, to our point earlier, is it should be an actual versus expected, right? I check this value not because, I don't know, feels good. It's because if actual does not equal expected, they've laid out a path for me of how to return the value back to the expected value. right? Everything we look at should be, okay, great. What can I do to control that? Right? If you tell me that I'm tracking humidity and you're like, okay, great. What are you going to do about that? And they're like, well, we just like to know. Cool. Are you planning on putting any kind of humidity controls in? No, then don't track it, right? Like it has an impact. Okay, but you're not doing anything about that impact. So don't worry about that data set, right? And it's coming from the floor where we've already got so much to do. Asking anybody to do a bunch more stuff doesn't make sense. So we have to be very efficient in what we're asking operators to either record if they are recording something, right? Or if we're going to build calculations, let's build the most simple, impactful, driven, how's this going to change us on a daily, instead of, ooh, let's build a profile of how this may work if I have a different product mix. Okay. Are you running the products the same each time? No. Well, then this model doesn't matter at all, right?
Right.
It's built on noise.
So if we look at a machine, and what I'm trying to understand right now, and also once again from the perspective of somebody that has not incorporated automation data tracking in their facility, what are probably the most common 3 items that we would track? I would imagine output, like parts per hour. That's a pretty big deal because that's directly tied to revenue.
Yep.
What else would there be?
So, and it really comes out into buckets. So I always tell people first go regulatory, right? Anything that you have to record, because if it's not recorded, will shut you down, is your best data collection. So if you're thinking about discharges is a big one, right? So I got a local pollution control agency, what my discharges are per day. And it's through a calculation I do. That's a flow meter and then some other calculation. Cool. Go do that data point. If you're recording that, anything regulatory, I always put number 1 because that's the one that'll shut you down.
That makes sense.
With regulatory, as a quick second under there, and it's still under regulatory, is the OSHA stuff, right? Any safety health stuff that you have a person recording that doesn't need to be, right? Those are things that will give you real-time metrics on the floor, right? And will keep you out of trouble because anybody who's gone through any of these environments, right, where they're looking for these, one of the biggest things when data collection happens, it's auditability, right? It's, can you show me all this stuff? How much time do we spend gathering all that for a future audit? Let the computer do it for you, right? That saves you a ton of time, effort, energy right off the bat. The next one, like you're saying, is I go to business metrics, right? So go from what is your boss being, right? What is the plant manager? What are their 3 business metrics, right? If it is yield, if it is uptime, if it is parts, whatever the flavor is at the time, pick those 3, right?
Yep.
Find out those data points that come from there and digitize those data points, right? Find a way to digitize it. Now, notice I said digitize, not automate. So digitize that part per million example you give me. You're like, yeah, but there's no machine out there that can count every widget we make because of the way we do. Cool, right? Not a problem, right? That's not digitization. That's automation, right? Where it records and sends it. Digitization is, we have a guy at the end of the line who every bucket as it fills up, we count it as a bucket. Cool. That's a unit of measure. So do you have him taking a log on that? I sure do. It's a piece of paper. Okay, so now that piece of paper, when he recorded that bucket, who knows about that? Only people who come down and look at that piece of paper. Instead, let's do a digital screen. It's an Excel spreadsheet. I don't care, right? Step 1. I put it on an Excel spreadsheet. Now when I report 1, that knowledge of 1 being produced is available digitally to anybody who has access to this, right? So instead of it being on that piece of paper there. So now that means immediately, let's just say that number is important and I'm looking at the spreadsheet, I see it the same time it's entered. No time delay, right? So that's the kind of process you can get into is what do you want to know right now? And most of that is stuff that you have to have people gather and aggregate. So
which that's helpful because that's what I didn't understand was, if it's a safety metric, like is everybody on the line wearing their safety glasses? I'm thinking, well, how could you have a sensor that would measure that? But no, it's just a process of having that safety officer put it into an accessible format. So, okay. So if we're tracking these data points, some of them may have a sensor that can measure them. Some of them may not. What's the hardware that I need? Do I need to go buy a piece of hardware that is going to interface with the eventual systems I use to automate or whatever it might be?
So I'll tell you, and that's where it really comes into place because believe it or not, you probably have some version of all this stuff around, right? I mean, really and truly, when I talk about digital transformation, I'm software agnostic, right, and hardware agnostic, because really it's a use case. So first you need, and like we talked about, you need something that can do the kind of what we call contextualization, right? The interpretation portion. So I've got a data point that says 4. I've got a table that tells me that the limit is between 8 and 4, and now analyzes that point between those two, right? Not talking to PLC, not to give an output, just to do the calculation and give me a visualization. So that's usually a software package of some sort. The nice part about it is the way these are built is it can talk to multiple data sources. So that calculation you want to do, you can pull data from the line over here. You can pull it from your ERP system. You can pull it from your CMMS system, right? Your material system that says, hey, what is my hour runtime limit for this? Let me check against how many hours it's actually run, because I have a run limit on it right now, right? So I know, instead of a human checking that runtime, I know, okay, it's past that limit. I need to set up an alert that says you need to go do hours on this one, right? Automate those kind of checks. So you can connect into different things like that. As far as the hardware for sensors, it's the list used to be really small. It's borderline endless now, right? Whatever, if you Google, how do I measure this remotely? And again, it's anything that you can do digital. It could literally be a pulse that said, yes, this is open or closed, to something way more in depth of what percentage open or closed of this valve is, right? My recommendation, again, as you're looking at how to get those sensors in there, would be, again, are they necessary, right? Did they come from that metric flow down where you're like, hey, I really need to know that, right?
Right.
If there's not a mechanical sensor, and most of the plants that we're talking to, if you talk to your integrators, like, hey, I really want to get a sensor on that, they'll love to tell you what to get.
Right.
The other part, though, is for human recording this stuff, getting it into digital, there's a ton of tools that can be used, right? There's some that are easy, there's some that are hard. Some people can make them really and truly at your simplest is an Excel spreadsheet, right? You can just fill it out there, and that's already digital. So now it can be captured. That's the first kind of step. Finding a software so you can keep doing that, so you don't have a bunch of Excel sheets, probably your next step. But you can see that you can literally graduate into that. The first step, right, literally being the digitization, so that anytime you want to write write a number down, you go, okay, does somebody need that number right now? And the answer is, if the answer is no, you should be writing it down, because you're a human. What are you doing writing numbers down, right? But if the answer is like, yeah, that's really important because it needs to get to that person so they can make a decision, then you also shouldn't be recording that number, because that number should be hopefully digitized. If you can't afford to digitize it, now you're on your third, which is, okay, fine. Humans got to record it, but record it in a digital right off the bat. Don't write it on a piece of paper and transfer it. Do it right at the point of entry. So as soon as you enter it, everybody knows that number.
Right.
Is kind of how I recommend that happens.
So if I was going to go shopping for, that next step above the Excel spreadsheet, what would I be looking for? An ERP?
So they usually fall within what are called like historian systems, right? So I'm actually an endorsed system integrator for one of them. So one of them is the OSI Pi system. That's used across a bunch of different industries, oil and gas, chem manufacturing. There's also a tool called Canary, which is quickly growing in popularity. It's a lighter touch, but still has a ton of the capabilities and is extremely useful. And I've worked with customers on that one. Inmation is yet another one, which actually has the ability to, instead of using pre-built blocks, you can actually really get in and do some fancy stuff. Again, it's a lot of these tools. Ignition's another one. These are kind of those contextualizer levels. And usually what they do is they allow you to connect to all the data points and then contextualize them in equations, creating events for them, aggregating them, things of that nature. And then each of those usually also have an attached visualization package, right? So now you can see those output values, right? Because a bunch of people use HMIs, which is great because that's the data on your screen at the point of use, the human machine interface. What is that data right now? But if you want to gather all that stuff and do calculations to it and put it on another screen, that's where the tools you're talking about, right? How do I bring this all together? And so and the nice part about this, Nate, is none of this is, hey, go wipe out what you have because you need to get this. All of the things I'm talking about are all meant to be integrated with things you already have in place. The tools I talked about are laying on top of what you have. Nothing I'm talking about is coming into your plant and saying, hey, that PLC machine over there can't have that type. It won't work on this, right? It's saying, no, it's got input and output points that are really good data points that I'd like to know. Let me get those. I don't care how it's controlling the machine. I just need your input or your output, right? not trying to get into the control mechanisms, not trying to change anything like that. It's all that available data.
Okay. So I know that we have a hard stop in a few minutes here, but I wanted to know if real quick you could give us a little bit of information about the aging workforce, transfer of knowledge side of things.
Yeah.
What are the systems that are used to do that? How do you get this experienced operator to know when to record something, how to record it, and then to provide it to somebody else?
Absolutely. And I'm going to give a plug for my own tool on this one. So the part that was missing for a large part, in my opinion, right, was we could get data, we could put it in these visualization tools, everything I've told you about. So we could show on a screen, hey, all that stuff you entered, it's bad, do something. And we'd flash a light at them or something. And that was it. Right. Then we'd hope that the human would go to a procedure and follow the procedure correctly. Whew, it's a big hope, right? That's to know there's a procedure is the first one, right? We're like, yeah, remember we trained you on it, right? And then to follow it through and understand what you're actually supposed to do as corrective actions, a whole nother thing. So that's the part where I saw the biggest opportunity, because all these other tools exist, right, that allow you to gather the data, and it tells you, go fix it. How to fix it is the next part. So if you can digitize, so procedures are where I go. I started from that. That's what I was trained on. But of course, I had people watching me to make sure I was doing the procedure and checking the response and all the stuff along the way. I wasn't operating alone. If you are operating alone, a digital procedure, and we have a tool called Ops Tracker. It has eForms. It is literally a drag and drop. And if you look at these hands, I don't do programming. So this is no code, low code, no code, right? It's a user tool. It's used for manufacturing execution systems in pharmaceuticals. So it's way heavy duty as far as auditability, all those things. But I use it because what it can do is it can give you if-then statements. So instead of a normal checklist that says do step 1, 2, 3, 4, 5, what I can do with this tool is it says, okay, this is how you are out of specification. Now I go to a form and it says, cool, you're out of specification this way. Check this. Is that happening this way? Yes or no? So instead of saying, okay, now select these doors like normal procedures do, it knows, yes, I picked this one, so don't worry about these other two and all their side actions. Take me to the next one. So it's a dynamic workflow. It brings to you what you have. The other nice part about it when I talk about Watch Team Backup is instead of saying, hey, go figure out what that tank level is to figure out what my next step is, well, your tank level's digitized. Why are you having a human go figure out a number so you can synthesize it in a procedure? Have that digital value available in the procedure so it makes the decision for you. So it doesn't tell you to go refill the tank if it's less than 75% because it knows the tank is at 82%. So it won't even give you that step, right? So really making it dynamic and form fit allows you to not just say, hey, the system knows what's stated in. Actual does not equal expected. Here are your steps to take actual back to expected, right? To close that loop. So when we talk about automation, that's a control loop. Right? That's what we do with the control valve. That's how we change temperature in our thermometer. That's straight automation. Humans cannot be automated. But what we can do is with digital procedures like eForms, we can help guide them through that using the technology on the floor to help give them input, right? Have their level of knowledge combined with it and take them through a process of things we can never automate so that they can do it in the same way. So we can standardize those operations. So the next time it happens, on the Monday morning, when I see that there was a disturbance over the weekend and I'm like, oh God, I look and I go, wow, yep, I see they followed the procedure. They did an ad here. They resampled and it brought it back into spec. Wow, we're still in spec. And that's the end goal. So you come in Monday morning, you're always in spec.
Fantastic. Well, very helpful, Kevin. I really appreciate you coming on today. This clarified a lot of things for me, and I'm sure it did for a lot of people that would listen to it as well. So thanks a lot for coming. If somebody wants to get a hold of you, wants some help with some of this stuff, how do they get a hold of you?
So you can email me at kwhite@eisinc.com. And feel free. I'm always open to talk about this stuff.
Awesome. Thanks a lot.
Thanks, Nate. Appreciate it.